Let me start recording this first of all. All right. So before we start, I think last week you all studied quadratic functions, right? So she wanted me to check with you guys if you have any questions regarding the quadratic function. So I'll do a small kind of a recap of the quadratic function, important things in there. And then if you have questions, you can ask me. Then we can move to the today's class, which is about exponential functions, right? So last time when you were learning about quadratic functions, you can see what I'm writing here. Everybody good with that?
Yes, sir.
Okay. So a quadratic function has a form of this kind, right? So ax squared plus bx plus c. And then in terms of the quadratic function, this a we said cannot be equivalent to 0 because if a becomes 0, this part kind of goes away, then it becomes a linear function, right? That's the first thing that you notice. And in terms of this a, b, c, we call as real numbers. So those are like regular numbers, right? So as an example, if you see a quadratic function, you can see an equation like this form. Right? This is just a general quadratic function. So that's the first thing. So when you see an equation, the first part is for you all to be able to identify whether that's a quadratic function, right? So then when you have a quadratic function, we said a couple of things. The quadratic functions in terms of the graph of a quadratic function has a parabolic shape like that or something like this, right? So in each of these cases, we say um, these functions are symmetric around the axis. So you guys learned something called the axis of symmetry. And then also we learned something called the vertex of the function. So if you have a function that opens up like this or the parabola open up like this, we say the vertex gives you a minimum value. And then if you have a parabola that opens this way, we say the vertex gives us the maximum value of that graph, right? So the first thing then is for us to understand how to find this vertex point. So I'm sure in the couple of sections back, you learn when you have a parabola how to find the vertex by writing it in terms of the vertex form of an equation. But in terms of the quadratic functions, what we do is the vertex, when you're finding it's a point, so you have like a x value and a y value. The x value can be found by using negative b over 2a. Whatever the b value you have in here, negative of that number, divided by the 2 times a. And then the y value of that can be found by using whatever you found for the x value if you evaluate the function by using that point, right? So any questions with that, how to do it, or you have any questions regarding that? So I guess silence means we are good, right? Then the second thing, so that's the first thing. Then the second thing we are interested in is once you identify the vertex, we wanted to see whether these functions we call opens up or opens downwards. Or in terms of the mathematical, we say whether it is concave up or concave down. So we can find that by finding or looking at the a value of this function. So if this a is greater than 0, we say the function is opening upwards like that. Or if a is less than 0, we say the function is opening downwards like this. So this one will be a concave upward, and this will be a concave downwards. That's the second thing you guys learn, right? Then the third part is since we know any type of parabolic functions are symmetric around what we call the axis of symmetry, so how to identify the axis of symmetry? So when you're finding the axis of symmetry, what we do is in terms of that vertex, whatever the x value that you get is going to be the equation of the axis of symmetry. And we write it by saying x is equivalent to, in this case, in general, it's negative b over 2a. So we write it as negative b over 2a. Very good at that. Any questions on any of those things, first of all? All right. So then that means the next thing that you discuss in section 2.8 is when you have a quadratic function, how to identify the zeros of the quadratic functions. Right. So when you say the zeros of the quadratic function, there's two kinds of zeros. So like where is the x value 0, what happens to the y? Or when the y value is 0, what happens to the x? So when the x values are 0, what we are saying is where is this graph is going to cross the y-axis, right? In the equation we have, if you use x equivalent to 0, these numbers goes away. So your function will be equivalent to the constant value, right? That will be the point that this graph will cross the y-axis. So the first kind, we can say when x equals 0, what is the y value, or in other words, the function value, that will be the constant that we see in this function, right? Then the second kind of zeros that you will see is when the function is equivalent to 0, or in other words, the y value is equivalent to 0, right? So when that happens, what we get is when the y values are 0, that means where this graph is going to cross the x-axis, the points that this graph will cross the x-axis. So I'm sure you guys did problems. Some of the times we will have the graph crosses the x-axis at 2 points. Some of the times it will just touch at 1 point, and some of the times it will never cross the x-axis depending on the equation. But in terms of finding the zeros where this graph cross the x-axis, what we do is whatever the function, we set it equivalent to 0 and then solve for the x values. So we need to find what are the x values that this happens. So when doing that, then the next thing we talked about, I'm sure you guys discussed, is like if you cannot find the zeros of this type of equation by factoring, so there are a couple of ways to do this. You can graph and find where it crossed the x-axis, or you can factor and find where it, what are the x-intercepts, or you can do complete in square and then find out the x values. Or finally, in the text, they also talk about this quadratic formula, which looks like this. X is equivalent to negative b plus or minus square root of b squared minus 4ac over 2 times a. So those are the methods that we use to find the zeros of a quadratic function. Any questions on any of those things? You guys are very silent. That means you have mastered all this material, right? So, all right. Um, then, do you guys have any questions from any of the homework or any of the questions from the exercises in the text that you want me to help you with? All right. That means no questions, I guess. So if you have any questions, let me know. Because your test on Thursday might have questions from quadratic functions. So just let me know if you have questions, even after the class is over is fine. All right, then if you don't have any questions from the quadratic functions, then we can go and start the chapter 3, which is about exponential functions. So let's start chapter 3. And then the today's lecture is from section 3.1, which is about exponential functions. So when I'm teaching the exponential functions, I just wanted to go back and review some of the things that we know about the exponents. So we'll do that first, and then we'll look at the equation of exponential function, and we'll discuss the important things in terms of exponential functions. So this first part is what you have seen in chapter 1 of your class material. You have worked with this, or you have learned these things in previously, right? So first of all, when you see an exponent, that means something like this, right? 3 to the power 2 we call has an exponent. So the meaning of this one is like 3 times 3, right? So what this one means is, first of all, this 3 we call as the base of the function, base of the term, and then this part is called the exponent, right? So when you see the exponent part, what it's saying is the base is multiplied that many times, right? So if you see 5 to the 3, that means like 5 times 5 times 5, like that. So that's the first thing you've learned. And then the next thing that you guys have learned in previously is how to deal with exponents, right? So if you have exponent, what type of things we can do. So in general, let's say if you have an exponent of a to the power x, right? One of the things you see is if you get multiplied this exponent with another exponent with the same base and exponent part as y, what we can do is we can combine this and write it as a times x plus y, right? Everybody good with that? Similarly, if you have a to the x and then a 2 outside, that means this will be equivalent to like a to the 2x. Or if you have a and a negative exponent, then we can write it as 1 over a to the x, which means like the reciprocal of a to the x, right? Those are some of the things that we know about the exponents. So any questions or concerns about those exponential rules? There are other things, but I'm only using the things that are helpful or needed in terms of learning exponential functions, right? So when we are doing calculations with exponential functions, we might have to use some of these exponent rules. So that's the purpose of reminding you about these things. Okay. Then the next thing that we need to do is look at what is an exponential function looks like, right? So in terms of the definition in the book on page 168 in your textbook, the exponential functions are defined as a function with a times b and the x is your exponent part, right? So if you have a function in that form, we say it's an exponential function. And in here, a and b are we call real numbers. And then your exponent part is the variable of this function. Then like earlier when you're talking about quadratic function, in order for the function to be exponential function, there are a couple of things need to satisfy. The first one is this a cannot be equivalent to 0. because as you guys can see, if a is equivalent to 0, what happens is this part disappears, or 0, you get 0 for a. Then when you have 0 times anything, the whole answer is a 0, so that won't have an exponential form, right? Then the next one is this b also cannot be equivalent to 1, because if you have b equivalent to 1, what happens is 1 to the power x, 1 to the power 1, power anything is equivalent to 1. So what you will get is the function equivalent to a times 1, which is like function equivalent to a, which means a constant function, so it won't be an exponential function. Then the third thing that we say is, and this b value will have to be greater than 0. So when you're saying greater than 0, any number greater than 0 except for b equivalent to 1. So if you have a function in that form, we call that function is an exponential function, right? So as an example, so we can think about a couple of exponential functions. So first one is like in the text, they talk about like a f of x equivalent to 2 to the power x. So if you have a function like this has the exponential form. In here, the a value will be equivalent to 1, and then the b is equivalent to 2. So in fact, you don't have to have like integers for the a or b. You can have a function like 192 times 1 half to the x. This is also an exponential function. In this case, a will be 192 and then b will be 1 half. So which is a number greater than 0 and then is not equivalent to 1, right? Or you can even have a function in that form. You will see a lot of these ones later on. So like 3000 times 1.03 to the power x, where now a will be 3000 and then b will be equal to 1.03. Um, is that clear to everybody? Any questions on that? How to identify an exponential function? All right. So no questions. So that means let's now think about what are these a and b represent in the exponential function. So in terms of this equation of f of x equivalent to a times b to the power x, a is called the initial value of the function. And then this b is called the growth factor of the function. So in terms of the exponential function, a, the initial value means the starting value for the function or the beginning value. And then growth factor means how much this function changes its value depending on the type of equation it has. So is that clear to everybody? First of all, those two. So you need to know when you were given an equation, how to identify the initial value and also how to find out the growth factor of the function. Okay. Any questions so far? Right. All right. The next thing then we are interested in discussing for an exponential function is how to identify these initial value and the growth factor. So let's start by the initial value. So if you have a function of f of x equivalent to, let's say, 3 times 2 to the power x, when you're finding the a, which is 3 in this case, what that means is when x value is equivalent to 0, what you get is this function we'll get an answer of f of equal to 0, 3 times 2 to the power 0. This 2 to the power 0 is equivalent to 1 because any number to the power 0 is equivalent to 1. So that means when x equals 0, you get the A value. In this example, it will be equivalent to 3. So if I'm interested in finding the initial value of the problem, that's one way to find the initial value. So based on the given information, if you look at when x equivalent to 0, what will be the A value will give you the initial value of the problem. So that's the first one. Then in terms of the growth factor, so that will be the number that this function will increase. So as an example, if you have a function of f of x equivalent to, I use the same function, 3 times 2 to the x. So we know when x value equivalent to 0, the function is equivalent to 3. But if you get like x equivalent to 1, then the function will be equivalent to 3 times 2 to the 1. So x equivalent to 2, the function will be equivalent to 3 times 2 to the 2, which means like 3 times 2 times 2. And then if x equivalent to 3, this changes into 3 times 2 to the 3, which means 3 times 2 times 2 times 2. We know that from the exponential rules. So you guys can see now each time when we change the value of x from 1 to 2 to 3, what happens is the function value or the y value or the f of x value increase by the growth factor, right? So that's one way to see what this growth factor, how that affects in terms of the function value. And then inside this growth factor, we have something called the growth rate. So that's the next thing that we are interested in finding out is what is this growth rate means. So for that, we use a different function and we say if you have a function like f of x equivalent to 3000 times 1.03 to the t, this is an example that they use in the book. Uh, so we see that this function has a or the initial value of 3000 and a growth factor of 1.03. And then, however, this function is also described as growing. So when you write like this growing growth factor like that, what it means is this function is growing at a rate of 3%. So the um, so the growth rate for this function is 3%, which means like 0.03. So how do you identify the growth rate when a function is given like this? Is from this b value, if you subtract 1, you will get the growth rate of the function. So some of the times this growth rate will be an increase in rate. If that's the case, your b will be a number more than 1. And then if you have a growth rate which is a decrease in rate, then your b will be a number less than 1. So we still subtract 1 in order to identify the growth rate of the given function. So that's the next thing that we are interested in terms of exponential function. So three things. One is what is the initial value. Second one is the growth factor of the function. And then the third one is the growth rate of the function. Those are three things that we are interested in finding out when you have an exponential function. So then after that, if I take just general information about the exponential function, let's say if your function is f of x equivalent to 3 times 2x, like I said earlier, the shape of the graph of this function is one of the things we are interested in. So we can graph this function by taking bunch of points in the graph. So we start by, like earlier, when x equals 0, the function will be equivalent to 3. When x equals 1, the function will be equivalent to 3 times 2 to the 1, which is 6. When x equals 2, the function will be equivalent to 3 times 2 to the power 2, which is 12. When x equals 3, this will be 3 times 2 to the power 3, which is 24, or it changes from the previous value by a growth factor of 2. So 12 times 2 will be 24. So now once you have those points, if you plot them in a graph, you see the x value at 0 will be like 3 here. And then when x value is 1, the graph will be like 6. This is not according to the scale. I just want you to see the shape of the graph. And when x value is equivalent to 2, that number will be a number like this. And then when x value equivalent to 3, it will be a number somewhere in here. So in terms of the graph of an exponential function, it will have this type of a shape, right? And then if you go towards the negative side, that means when x is equivalent to, let's say, -1, the function we can evaluate by saying 3 times 2 to the -1, which means like 3 times 1/2 from the exponential rules. So that will be like 3 over 2 or 1.5. So when it's -1, it will be a point somewhere here. Like that, you can find the values that goes on this way too. So that's how the shape of an exponential function will look like. Then once you have that exponential function, we can talk about the general properties of exponential functions, like the domain of the function, the range of the function. Is this function increasing or decreasing? Or is this function has a maximum value or a minimum value? All those properties you learn in chapter 2 can be described in terms of these exponential functions by looking at how the domain is defined, the range is defined, and what is the maximum value means, and what is the minimum value means, and so on. So those are the other things that we are interested in terms of exponential functions. Any questions on any of those things? Anybody have any questions? All right. Since no one has any questions, so I'm going to do a couple of examples from the exercises, and then we'll go from there. So the first example I'm going to do is in page 170 from the exercises, exercise 1. So page 170 in your text, question number 1. So the function, the exponential function given to us is like this. F of x is equivalent to 1000 times 1.1 to the power x. And then they want you to answer the following concerning this function. So the first one is part A is asking what is the A or the initial value of the function. So the A will be the number or the coefficient of this exponential part of the function. So that means it's equivalent to 1000. Then part B is asking what is the growth factor of this function. So we know the growth factor is equivalent to the B, which is in this example is 1.1. Then part C is asking the growth rate of the function. So we know the growth rate means the B value minus 1. That means B value is 1.1 minus 1 will give you an answer of 0.1. So as a percentage, zero point 0.1 means 10%, right? And then part D is asking, if you have this function, complete the table given below. So you have a table that you need to find bunch of values based on this function. So x value and the f of x value. And then the x values are like 0, 1, and 2. So they want you to find the y values for this function when x equivalent to c. See these numbers. So you can do that by plugging those numbers into the equation. That's one method. Or by using the understanding of what is this growth factor means and the initial point means. So if I am doing this problem, I'll take a look at and say like x equals 0 means my initial value. Or when x equals 0, plug into this equation, this part becomes 1 times 1000. So the first value will be 1000. The second number will be x value 1 times 1000. So like this, 1000 times 1.1 will be when x equals 1. And then when x equals 2, that number will be 1000 times 1.1 to the power 2, or we say 1000 times 1.1 times 1.1. So by using that, we can find these two numbers and fill up the table values. So that's the part B. Then part E is asking, is A positive or negative? We can see the value of A is positive. And then is the function increasing or decreasing? So if you have a positive growth rate, the function is increasing. So in this case, the function will be increasing. Or you can also remember from the chapter 2 material, when you have an increase in function, if the x values increases, the function value or the y values also has to increase. Or we say when you go from left to right in the graph, if the y values also increases, then it is an increase in function. So that's how you answer these type of questions, and you have several of them in your text. Any questions on doing those questions? That one. All right. Then we go to the second one, second example. So second kind of example is like question number 5 through 10 in the textbook. So I'll do question number 7. So in this example, they're saying some of the values assigned by an exponential function are given in the table below. In that table, they have given bunch of values, x and the function. So x value is equivalent to 0, 1, 1 and 3. And then the y values when x equals 0, the y value is 3. When x equals 1, the y value is 12. And then x equivalent to 3, we don't know the y value. It is not given to us, and they ask us to find that value. So they call it as k. Now using that information, we should determine the value of the k. Now we can do this by using several methods. There's not only one answer when doing math. You can use different methods. But if you are using the equation, what we know is in general, when you have an exponential function, it has this kind of a form. In that form, when x equivalent to 0 will be the a. So in this case, a will be equivalent to 3 from the given information. So you can rewrite this equation as f of x equivalent to 3 times b to the x. Now, if somehow we can find the value for b, then we have a function. So once you have the exponential function or the equation of exponential function, we can find out when x equals 3, what will be the value. That's one method. So let's see, in order to find if you're using that method, then what we need to do is by looking at this other point that is given to us, we know when x value equivalent to 1, the y value is equivalent to 12. So that means like this, 12 is equivalent to 3 times b to the power 1, because x equals 1, the y is 12. So that gives you an answer for b as 12 divided by 3, which is equivalent to 4. So if you rewrite the function now, what you have for this data set is a function where the initial value is equivalent to 3 and the growth factor equivalent to 4 to the exponent x. So that's your function. Now, if I wanted to find when x equivalent to 3, what we do is we can evaluate this function at x equivalent to 3 in this form, 3 times 4 times to the power 3. Right? So by simplifying, we can identify the value of k. So that's one method. Or the next method that you can see is if this function is an exponential function, we know when you go from 0 to 1 to 3 like that, each time the function value from the initial point get multiplied by the k value. So if you look at from 0 to 1, the function has been multiplied by 4 to get 12. That means your the growth factor is equivalent to 4. So if you have that number, the next number when x equal 2, it will be 12 times 4. And then the next number when x equals 3, it will be 12, whatever that number times 4 again. So what I mean by that is like this. So based on this data set, if I put all the remaining numbers, 0, 1, 2, 3, x value and f of x, we know this number is 3, that's your initial value. And we know that when x equals 1, the value is equivalent to 12, which means 3 is multiplied by 4, your growth factor is equivalent to 4. This is only if you know that this data set represents an exponential function.
Can you please move your paper up?
Oh, sorry.
Thank you.
Can you see now?
Yes.
Okay. Sorry about that. So at x equals 0, we know the value. X equals 1, we know the value. That means my b is equivalent to 4. So once I know that, since in the beginning, like I said, what the growth factor does is it increases the function value, or it gives the function value by multiplying the previous answer by that number. So then the next number will be 12 times 4, which is 48. And then the next number will be 48 times 4, which will be your k. So that's the second method of finding the missing value in this example. Is that clear to everybody? Any questions on that? All right. Silence means no questions. Let's look at another example, which is kind of a different one from the previous one. Like the question number 11 in your book. So again, what you were given is a bunch of data points you have a x and a function value of f of x. And then this time they have given when x equals 0 and x equals 1 and x equals 4. X equals 0, we don't know the value, so they call it as k. That means we don't know the initial value of this example or the equation. Next, x equals 1, the number is 14. X equals 4, the number is 112. So what they're asking us to find is determine the value of b. So when you're doing this, if you think about it, so again, what we're doing is f of x is equivalent to a times b to the power x. I like to do it this way because that way, you are using the same equation or the same technique or the method for all of them. But if you're using a different method, that's fine as well. So once you have that, in order to find a, I need to will be the initial value. So if I write in terms of the given information, my initial value x equals 0, the a is equivalent to k, which is a variable, times b to the x. Now, if I wanted to find k, I have like 1, 2, 3, 4 unknowns in here. So if I know 3 of them, I can find the value, the machine value, or the k. So in order to do that, then first we need to understand what is um, the growth factor for this problem. So we need to find what is my b value is. So once you know the b value, then we can use one of these points which has an x value and a y value, and then find the remaining missing number, which is your k. So how do you find the b or the growth factor? So that's what we wanted to see, right? So what we know is in terms of this function, now if I use these 2 points given to me, so when x equals 1, the function is equivalent to 14. When x equivalent to 4, the function is equivalent to 112. So if we are doing this problem, then we have to see, okay, how can I use this given information and find the b value, right? So if I type those points into this equation, so when function value equivalent to 14, I will get like k times b. Both of them I don't know at this time, but I know the x value is equivalent to 1. Similarly, if I use the second point, that means 112 is equivalent to k times b to the power x is equivalent to 4. So by using this, we can identify the b if you can somehow get rid of one of the variables, right? So in this case, what we're doing is we can divide one equation from the other one. So like if I call this one as 1 and this one as 2, right? So if you divide 1 by 2, what you get is 14 over 112 on the left hand side of the equation. And then you are getting k times b over k times b to the 4. Now it does not matter if you divide 2 by 1 or 1 by 2, the first equation by the second one, or second equation by the first one. That does not matter. So when you're dividing like this, these k's cancel out because in both numerator and denominator you have k. So what you will get is 14 over 112 will be equivalent to b over b to the power 4. We know from the exponential rules, if you have like 1 over b to the 4, that's the same as bringing this to the numerator and writing as b to the power negative 4. That's why we reviewed that exponential rules previously. If you have this, that's equivalent to that. If you have that, this is equivalent to that. Which means this number, I can write it as b times b to the minus 4. Is that part clear for everybody? All right. So once you have that, Then what we can do is, since the bases are the same, this is like having a 1 here. So this will be like 14 over 112 is equivalent to b to the power negative 3, right? Now, since we have the negative exponent, to make it positive is we take the reciprocal of that. So that means I can rewrite this equation as b to the power 3 by switching the numerator to denominator and denominator numerator. Okay. Is that part clear? Any questions um, on that one? All right. So that means no question. So b to the power 3, if we divide 112 by 14, the answer will be equivalent to 8. Now, since we wanted to find the b, what we do is take the third root from both sides of this equation, getting a b value of 2. So once you have that, now in terms of this problem, we have the equation of f of x equivalent to a, or in this case k, times 2 is my base, the growth factor, to the power x. Now if you use this equation, you can find the a or the k value by using one of these points. So when the function is equivalent to 14, a is equivalent to k times 2 to the, this is 14 when the number is equivalent to 1. So equivalent to 1, and then the k will be, if you divide both sides by 2, equivalent to 7. So that's a way of finding the missing value of k, or the initial value. Is that clear to everybody? Any questions? Or second method is by understanding the concepts of the function. Once you know the b value, all you have to do is divide the x equals 1 divided by the b will give you the x equals 0 value, or the previous value, because x equals 1 get by multiplying by the base the initial value. So that's the second way to think about it, but any of those methods will be fine. But first you need to find the b value. Once you, or identify the b value, then once you have that, you can calculate the initial value or any other point. Any questions on that? All right. That's the third example. Now let's do another one. Only just one part, one of the parts of this example. So in page 173, you have questions where a graph is given to you. My graph will be not according to the same scale as, but I will mark some important points. So you see a graph like this, and then we know this will be an exponential function. So this point there where this graph crosses is given as 8. So in other words, that point will be x value 0 and y value 8. And then another point in this graph is when x value is equivalent to 1, the y value is given as 4. So we know these 2 points. We have other points. Let's just use these 2 points and see um, how to find the equation of this graph. So when you have a equation, we know how to graph. This is the opposite of that. When you have the graph, how to find the equation of that. So again, what we do is we try to identify, since this has an exponential shape, we try to identify the important parts of an exponential function, which is like, in general, exponential function has a form of a times b to the x. So we are interested in finding out what is the a value. A is when x value equivalent to 0. So in this case, when x value equivalent to 0, I can see it's equivalent to 8. So that means my a is equivalent to 8. So then I can write the equation as f of x equivalent to 8 times b to the x. Now, if I can find the value for b, then I know the graph, I know the equation of this function. So like earlier, two methods. One method is by using one more point in this graph. After you come here, you can do like this. We also know when x equals 1, y is equivalent to 4 by observing the graph. So that means if I use this equation and then say when y equivalent to 4, a is 8, b I don't know what I wanted to find, and x is equivalent to 1. So anything to the power 1 is that. So that means if I divide both sides by 8, what I get is 1/2 will be equivalent to the b. So that means my equation of the function is f of x equivalent to 8 times 1/2 to the power x. Is that clear to everybody? Any questions on that? Or the second method is, since we know the initial value when x equals 0, the function is equivalent to 8. And when x equals 1, we can also say the function is equivalent to 4. So that means when you go from 0 to 1, in order for 8 to change into 4, the b has to be equivalent to 1/2. So that's by understand the concept of the b means the growth factor, how much the function value change from the previous point. Um, any questions on that part? So if you are given any type of graph, you can identify the initial point, find out the initial point, and then find out another point, and doing this calculation, you can identify the equation of the graph. Any questions from anybody? All right. Silence means no questions, I guess. We'll do one more application problem this time, like the question number 15 in your textbook. And then see, after that, I think you should be able to answer any questions in this section about the exponential functions. So in this example, they are saying a town has a population of 600 people in the year 2010. So at 2010, the population is 600 and is growing at an annual rate of 3% a year. So they are saying the growth rate for this example is 3%. In terms of a decimal, that means like 0.03, we know that. And then let t represent the years after 2010, and let f be the function that to each time t after 2010 assigns the population of the town at time t. Determine the formula for this given information. So what they're asking us to write is a function based on the time t. If this has an exponential form, this will be a function of a times b to the power t. T will be the time. So those are the things given to us. And then we start by saying the t at time equals 0 will be 2010. That means the initial point, initial value, or the a for this function will be equivalent to 600. So if you write the function f of t will be equivalent to 600 times b to the power t. Now we can complete the function if I can identify what is the b value. So from the information or the things that we know, if you have a growth rate of 3%, in order to find the growth factor factor. If it is increasing, what we do is we add 1 to this number. So 0.03 plus 1 will be your B value, which is 1.03. So that means my equation will look like 600 times 1.03 to the power t. This will be the equation of this population for this problem. Is this question clear for everybody? Okay. So I think I covered examples from all those kinds. Now that's all the material from this section. So it's time for you guys to ask questions, or if not, I think we will be done for today. And please ask questions because I don't want you to not know any of these things come Thursday. I did, somebody has a question. I did record the lecture. I will send it to your professor. She is the only person who has authority to get into Brightspace, and she will post it. And then I will ask her to post the book sections as well. I don't have access to the Brightspace page for her class, so that I can, but I can ask the. Yeah, I did record the lecture, and then I will be sending that to her as well, and then she will post it. Any other questions from this section? So I think the Thursday you have to come to class, and there is a, we teach part of the class, and then after that you guys will have the quiz, right? Okay. So has she assigned any homework questions from this section yet? Okay. So the final thing is, since she's not feeling good, if you guys have any questions from what we covered today, I will, my email is like this: skarunar@pnw.edu. So if you have any questions, can you guys see the email address? Actually, I can type it in here. So that's my email address in the chat box. If you guys have any questions from any of this material, send me an email. I will reply to it, or if you need more explanation, I can make a short video and send it to you as well. And in addition to that, if you have questions, you can also bring them to class on Thursday, and then when you come to class before we start the material for that day, you can ask me questions on that too. Sounds good? All right. So anybody else have any questions, or is everybody okay with the material? All right. So if you don't have any questions, so have a good day. I'll see you guys on Thursday.